Good morning, everybody. Wanted to do a quick make-believe linearization problem. This one's looking at a cart that's starting at the top of a ramp, goes down the ramp, hits a spring, collides, and squishes it. And they have two pieces of data here. One is they're measuring the height they drop it from, and then they're measuring the squish. Both are in meters, so we don't have to convert it. And then up here, it also tells us the cart's 4 kilograms. So first thing I do is when I see this, I have to make a decision. Am I looking at forces, energy, momentum? And so it's one of those three, right? Well, anytime I have a change in height, I'm gonna usually go think about energy. There's a collision with a spring, but the spring doesn't have mass, so I can't really do momentum. I don't want to do forces because the forces are changing. So if you look down below, they actually say, hey, this is our result. The student correctly came up with this. So if this was an FRQ, there'd be a part before this where you came up with your own lab. But here, they're giving it to you. Okay? So they give you the data, they measure the height, and they measure the squish. And then they said this student correctly comes up with an equation. And they do this a lot. That way you're not double dinged if you can't make an equation. They work with you. So the question they ask here is indicate what measure or calculated quantity can be plotted on an axis to yield a linear graph whose slope can be used to calculate the value of the spring constant K. So here we go. So here's my goal, is to get K. And then I'm going to look and see what did they give me in this problem. They gave me H, so I see H right here. And they gave me X. I see X right here. Well, the H doesn't have any powers to it. It doesn't have a squared. It's not in a square root. It's just H. Look at the X, though. The X is squared. So I didn't graph this, but if I were to just graph these two, what you end up seeing is a graph that looks like this. And you're like, what? That's not what I wanted. That is not a line. So if I just graph those, that's what I get. Now, on the AP exam, you have Desmos, so you could graph it real quick and see, oh, is it a line already, right? That's one option. The other is you can look, I want to give you the tools to look at the equations here. So here we go. See how the H is good. H is to the power of 1. There's nothing on it. We see the X, how it's X squared. Since that's X squared, I'm not going to graph X. I'm going to graph X squared. And this is why they give you that extra column. If they don't give it to you, write it right next to it. I'm going to literally calculate X squared. So I'm going to calculate X squared. So 0.5 times 0.5, I get 0.25. And here I got 1 squared, and I got 1.5 squared, 2.25. And 2 squared, and then 2.5. All right, 6.25. Okay, so if I were to graph this, X squared and H, I'm going to get a line. So down here, I'm going to tell you right now, in the X direction, let's have, actually, just however we solve this. So I'm gonna say H is gonna be in my Y and X squared is gonna be in my X. It's just what I felt like. That's what I'm gonna do. So I'm gonna put H here, X squared here. So the first thing I do is I put the units in meters. Here, X squared, since it's meters, it'll be meters squared. Okay. Now, I need to get out my ruler, and I'm going to label my axes. Okay, so first thing, you got my axes here. And my H's go from basically 0 to above 5. So maybe go to 6. So I got 1, 2, 3, 4, 5. If I go to 10, I'll only go halfway, so maybe 2, 4, 6, 8, 10. I mean, I could do that. 8, 6, 4, 2, 0. Not perfect, but it's okay. So 5.1 will be over here, okay? And then my X, I'm gonna go from basically 0 to 6. So maybe you do the same. Oh, sorry, 0. I'm okay. 4, 6, 8, 10. Right? Not perfect, but so I'm at 5.1. I'm at 6.25. About here. Not perfect, but about there. Okay. When I'm at 3.1 in H direction, 3.1, I'm at 4. So 4 and 3.1. Okay. And then 1.7 is down here, so there's 1.8, 1.7, 2.25. Kind of here. Not perfect, but right, getting close. 0.9, so that's 1, just below 1 is at 1. And 0.2 is at 0.25. If you look, now we're seeing, does that thing look like a line? Yeah, it does. Okay, good job. All right, so now, best fit line. Let's talk about rules of best fit line. It does not have to go through the first dot and second, and first dot. First dot and last dot. It does not. Second, it needs to have about the same above as below. And so I'm just going to try to draw a line. I mean, that dot's kind of bothering me, but I got some below, I got some above. It doesn't have to go through them. There we go. There's my line. So it doesn't have to go through them. Try to balance above and below and draw a line. Don't draw multiple lines. Don't draw a squiggle. Just draw one line. Now to find the slope, mine conveniently goes through 0, 0. Let's say it didn't, so that way I can practice with you here. So I'm going to circle, I'm like, ooh, see how it goes through the bullseye right there? Okay. And then up here, ooh, it goes through that one. I like that one. Okay. So if I want to find the slope of this, I'm going to look at rise over run. So it rise, so I got to figure out what that number is. So that's right here, and it goes right here. So if this is 2, this would be 3. So this is, if that's 3, 1, 2.5. Oh, geez. My scaling is not very good on this one. So let's see. This distance is 2. And I'm going to divide that by how many things I have, 5. So each line is worth 0.4. That's worth 0.4. That was worth 0.4, right? So this is going to be 2.4, 2.8. So this is at 2.8 right here. And this one goes up to 5.6. Because remember, every line segment is going to be 0.4. So vertically, it goes from 2.8 to 5.6. So it goes vertically 2.8. Horizontally, it goes from 4 to 7.6. So this one goes horizontally 3.6. So my slope here is going to be rise over run. Now, we have no idea what this means right now. So we kind of did this a little out of order, but I got a slope of 0.778. That's my slope. Okay, we're going to probably use it later because it told me I need to use it. Okay. So notice, by graphing that and that, I ended up getting a straight line. Okay. So notice, our points here looking at the exam. Did I label my axes? Yes. Did I plot the points? Yes. Did I draw a best fit line? Yes. Part D, calculate the value of the spring constant. Now we're down to the tough stuff. All right, so this is now going to be part D here. Well, I'm going to write out what I had here. I had 1/2 kx squared equals mgh. Now, I made the vertical axis y. So I made this y. Okay. Now I made x squared. I made that equal to the x direction in my graph. So I'm going to put x, not like an x, but like horizontal. Okay. Remember math class, we had y equals mx plus b? All right, so notice how y is by itself. So see how this is my y. I try to parallel this to what we did above. That's my x squared and that's my h. Well, I want that to be my y. I need it by itself. So I'm going to divide both sides by mg. So I'm just going to write down 1/2 kx squared, and this whole side's divided by mg. I think you'll do it that way, so let me write it that way. Okay. So notice, do I have this as like my y by itself? Yep. See, I have my x squared. That's going to be my x. Yep. And then this, all of the rest of the stuff. See, in my equation here is y equals mx plus b. This whole thing right here is going to be my slope. So this is my y, this is my x direction, and this is my slope. If I had a plus or minus here, that'd be my y-intercept. That's what this stands for, y-intercept. Okay? So, watch this. My slope will equal 1/2 k over mg. Well, I know what my slope is equal to. My slope is equal to 0.778. Half is 0.5. Ready? What's my m in this problem? All the way up here it says it's 4 kilograms. I have a bad feeling this has been out of focus the entire time. Please don't yell at me. And so the bottom is mg, so that's 40. So I got 0.778 equals 0.5 over 40. I'm going to simplify that. 0.5 over 40. I get 0.0125k. Now to get k by itself, I divide. So k equals 62 newtons per meter. All right. I know this is a lot, but I just wanted to give you another resource as we head into that AP test. You guys are doing great. Keep it up. Okay. Let's see. I'll get one last shot on here so you can see the whole page, but hopefully that helped a little bit. Remember, you got AP dailies that deal with linearization, so go check those out and just keep letting us know. All right. Keep it up, everybody.